Today we're going to do experiment number 11 from Chemistry with Vernier. This experiment is determining the concentration of a solution, Beer's law. We have another version of this lab that's very similar in advanced chemistry with Vernier. Experiment number 17 follows the same storyline. The students would have already prepared the standard solutions. Starting with a 0.40 molar solution, they would have done a series of dilutions by 4/5, 3/5, 2/5, and 1/5, respectively. So a student would have already done that particular step. So to start out with, I already have Logger Pro running on the computer, and I'm going to use the Vernier SpectroViz to collect the data for this particular experiment. Although you should keep in mind that this experiment can also be done with a Vernier colorimeter. It can also be done with a Vernier ocean optics powered Vernier spectrometer, and it can also be done with any of the several ocean optics spectrometers that we carry. So to start with, I'm going to take the SpectroViz spectrometer and I'm going to connect it to the USB port of this computer. And when I do, it should get identified automatically here. And so I should have an indication on the screen. Up in the far left of the toolbar, we can see absorbance is displayed, so it's been auto-detected. We can see a full spectrum displayed on the graph from a wavelength of 400 nanometers all the way up to 725 nanometers. That's the range of the SpectroViz, and we're ready to go. So my first step here, as with most spectrophotometers, is I want to do a calibration. So I'm going to take a blank cuvette and place it into the cuvette slot of the spectrometer. And the lamp is over on this side of the cuvette slot, and the detector is over on the detector array is over on this side. And so I've aligned that correctly there. And now I go into Logger Pro, and I'm going to choose from the experiment menu, Calibrate Spectrometer. In the dialog, it says that it's going to wait 60 seconds for the lamp to warm up. Now we're just about done. The warm-up is just about complete. It says to place a blank cuvette in the device and finish the calibration. So we click on that. And we click on OK, and the calibration is complete. That's all there is to it. Now, the thing that makes the array spectrophotometers nice is that in the past, you always had to tell a student, or you generally told a student what wavelength they were going to do the particular experiment at. But here, the student can determine that wavelength themselves. That's one of the beauties of this. And so what I'm going to do is just take a sample of, I'll take one of my standards, the 0.40 molar, and I'm going to put that down into the cuvette slot, and I'm going to do a full spectrum of that. And we're already in the full spectrum mode, absorbance versus wavelength. So I'm going to go ahead and click on Collect. When I do that, in less than a second, I have a full spectrum. And I'm going to click on Auto Scale just to fill up that fill the graph axes a little bit better. And I'm going to go ahead and click on Stop. So one of the beauties of doing this experiment with the SpectroViz is that instead of telling the student which wavelength to use, the student can discover that for themselves. So here we have a cuvette that has a solution that has a green color. That means it's transmitting green light, and it means it's absorbing very poorly. And if you look at that part of it's a nice teachable moment. If you look at that part of the spectrum, we can see that the absorbance of the green in the green part of the spectrum is very low. On the other hand, it's absorbing very well down in the violet to blue part of the spectrum, and it's also absorbing very well over in the red part of the spectrum. So I can use, for this experiment, a wavelength down in this region, or I can use one over in this region. Now what I want to do is change to a different mode of data collection. This mode that I'm currently using is called full spectrum, and I want to change to something in Vernier land that we call events with entry. And events with entry just lets me put in these 5 samples and take readings at my own pace and not have to do that against the clock. To access that mode, I'm going to go up to the left of the collect button over to where I see the configure spectrometer icon, and I'm going to click on that. And now I have a dialog box that really gives me 3 different modes that I can use. There's absorbance versus wavelength that I'm currently in. There's absorbance versus concentration, which is what I actually want to do for Beer's Law standards. And then finally there's absorbance versus time for a time-based experiment. So what I'm going to do is click on absorbance versus concentration. And what it's done here is it's actually selected for me, if I want to use it, a peak that's down here at 407 nanometers. It's also here in the graph. But I can also choose a different wavelength. So maybe what I'll do here is I'll uncheck the 407 and I'll go over into that red region, which also works, and maybe take this little peak right here and just click on that. Notice that it's left a little square point protector on that peak. And now, up here I have select wavelength checked at 656.8 nanometers. I like that choice, so I'm going to go ahead and click on OK. Do you want to store the latest run before switching to collection mode? Yes. By choosing to store that run, I keep a history of what's happening in this experiment. I've got actually, for a lab report, for example, I've got the full spectrum graph that I might want to include. But now I have a new graph down at the lower half of the screen that has absorbance versus concentration for each of those Beer's Law standards. I'm going to go up and I'm going to click on Collect and begin data collection. I already have the first standard solution in there. It's 0.40 molar nickel sulfate. So as soon as that value is stabilized, notice the live reading down in the lower left-hand corner is 0.713. I'll click on the Keep button just to the right of the Stop button. And I'm prompted to enter the concentration, which is 0.40 molar. And I'm going to click OK. And we've now kept that particular value right in the middle of the graph. Now I'm going to go right down the line. I'm going to go ahead and put in the 0.32 molar solution. It looked, even visibly, it might even look a little bit lighter to you. Notice that its value, there's a live cursor here, is a little bit lower. And it's down at 0.546. I'm going to click on Keep. And I'm going to enter 0.32 molar. In the same manner, I'm going to place in 0.24 molar nickel sulfate. Click Keep. 0.24. OK. 0.16 molar. And finally, the last standard is 0.08 molar. And I'm going to click on Stop. And there's my Beer's Law data. Beer's Law is the relationship between absorbance and concentration. You always hope for a linear relationship, and the students can discover that. They're also quite interested. There's a good indication of how well they prepared their standards when they put on a linear fit. To do a linear fit, up on my toolbar, we have a linear fit button. And so I'm going to go up and click on that. When I do that, notice that I get a best fit linear fit line displayed on my graph. And what a student would be interested in there is the correlation coefficient which is 0.9992, very good correlation coefficient. They'd also be interested in how close they come to the origin. Notice it's a real small y-intercept value. And sometimes they were a bit competitive in finding out who prepared their standards the best. The next thing we're going to do is the second objective in the lab was not just to discover that relationship, but to find the concentration of an unknown solution. So the next thing I'm going to do is I'm going to take my unknown solution and place it into the cuvette slot. And down in the meter window, which is still live, I'm going to observe its absorbance. And I see that absorbance is 0.355 molar. Now I'm going to go to the Analyze menu and choose Interpolate. I'm going to drag that box down to the lower part of the graph here where we can see it. Notice that as I do that, notice there's a little circular cursor somewhere as I move along that linear regression line, notice that it updates in the box down here the new concentration and the corresponding absorbance value where I'm displaying. So I had a value of 0.356, and so I'm going to move this until that absorbance value is 0.356, or as close as I can get to it. So there's 0.357, and I notice that the corresponding concentration is 0.21 molar, which is very close to the concentration that I prepared. So we actually use the concept of Beer's law a number of places across the curriculum. In our Vernier lab books. There's the two I mentioned earlier, which are the Advanced Chemistry with Vernier and Chemistry with Vernier lab books. But we also have in the Advanced Chemistry with Vernier lab book a second lab that makes use of it, and it's one that a number of chemistry people would know. It's the determination of an equilibrium constant Kc for iron thiocyanate, and it has a Beer's law as part of that experiment. And then also in our water quality manual, we have two instances. One when we determine the concentration of nitrate using a colorimeter or spectrometer. Another one where we use determine the concentration of phosphate, orthophosphate, that we make use of the same Beer's law concept.